Hi and welcome back. So in this video we kick off chapter 13 of our Macroeconomics 3 module, where we look at the impact of technological progress on employment in the short, medium and long run. Or rather, what does the technological progress imply for employment in the short, medium and long run? So we spent much of Chapter 12 celebrating the merits of technological progress. That we showed that in the long run, technological progress is the key to the increase in standard of living. However, popular discussions of technological progress are often more contradictory to this point. It shows that technological progress is often blamed for higher unemployment and for higher income inequalities. So in this chapter, we're basically going to see, or rather question, if whether these fears are groundless or are they true. So we'll cover this chapter by looking at four basic sections. So section 13.1 or section 1 of the chapter looks at the short run response of output and unemployment to increase in productivity. Then section 13.2 we'll look at the medium response of output and unemployment in the increase in productivity. And 3, we'll focus on the distribution effect of technological progress. And the last part will be part 4 or section 4, where we're going to discuss why some countries are able to achieve steady technological progress and others do not. So on that last part, if you may remember very well, another theme of chapter 12 was that for countries behind the technological frontier, technological progress is as much about imitation as it is about innovation. So this makes it sound easy, and the experience of countries such as China reinforces this impression that if one country cannot basically produce their own research and development, they can always imitate the same things that other countries are doing. However, it is not that easy. And if it was that easy, why are many other countries unable to achieve sustained technological progress and growth? This is the second set of issue we take up in this chapter as well. So from chapter 12, we represented technological progress as the increase in A, which is the state of technology, such that our production function was given by output being a function of capital and effective labor. Because our interest in this chapter is really technological progress, we would assume that the production function that describes output in the economy is represented by output being a function of effective labor. So this is because what matters for this issue is basically discussing technological progress, not capital accumulation. Hence, we ignore the K here. So we simplify it by ignoring capital for now and assume that output produces according to this production function. So under this assumption, output is produced using labor. So labor is the N. So output is produced using labor, and each worker produces a unit of output. So increase in A represents technological progress. So this basically means if each worker produces A, this will mean A is the productivity of each worker, which is understandable. Because as we've been saying, NA or AN means effective labor. Okay, so if this is so, A has two interpretations here. So one, it is the one that we've been discussing, the state of technology itself, as shown here. And the other is labor productivity or output per worker. So which follows from the fact that Y over N, output per worker, is equals to A. So this comes from making A subject of this formula here and finding A. So this will then mean that when referring to increase in A, we can use labor productivity and technological progress interchangeable to mean the same thing, A. Okay, so if output per worker is A, then what is employment, N? So N is basically equals to output divided by productivity. Yeah, so this we can refer to as equation 13.2. And from equation 13.2, which is labor is equals to output divided by productivity, it can be seen that given output Y, the higher the level of productivity A, the lower the rate of employment, and by implication, the higher the level of unemployment. So this then naturally leads to the question that when productivity increases, does output increase enough to avoid a decrease in employment? Because for N not to decrease, these two need to at least increase at the same rate. Okay, let's use a model to look at the impact of change in technological progress on output and by implication on employment. So the right model to use when thinking about the short and medium run response of output to a change in productivity in the short run is the model we developed in chapter 7, and we called it the ADAS model. So if you may recall, the basic structure of this model is that output Y is determined by the intersection of aggregate supply and aggregate demand curve. So they looked something like this, with the AS being upward sloping and the AD being downward sloping, and they showed the equilibrium by the intersection of the two, where there's equilibrium price and equilibrium output. So the S curve gives the price level P for the given level of output, and the curve is upward sloping. Increase in the level of output leads to increase in price, as stipulated by the AS curve. So the background mechanism of this was that the increase in output would lead to a reduction in unemployment, and the fall in unemployment would lead to an increase in nominal wages, which will lead to an increase in price. While the aggregate demand relation gives output for a given price level. So the AD curve is downward sloping, such that an increase in price leads to a decrease in output, or rather there is a negative relationship between output and price. And the background mechanism was that the increase in price leads to the fall in money stock. So the fall in money stock pushes the interest rate up, or rather increases interest rate. So the increase in interest rate reduces demand for for goods, and hence the fall in output. And this is the aggregate supply and aggregate demand interaction curve. And again, as shown, aggregate supply is upward sloping and aggregate demand is downward sloping. So according to our curve, given equilibrium output Y, employment N is given by the ratio between output and productivity, such that the higher the productivity, the lower the number of workers needed to produce the level of output Y. Or rather, the higher the productivity given output, the lower the employment needed. So this makes sense because we said one of the effects that technological progress or productivity has is on unemployment is that it reduces the number of workers needed to produce a certain amount of output. So what we seek to answer now is that in a balance or equilibrium economy like this, what happens to output, unemployment, and employment in the short run when productivity increases? For instance, what happened to this economy when there's an increase in productivity from A to A with an apostrophe? So this is what we look at. The safest answer to this is that it would depend on how the increase in productivity shifts the aggregate supply and aggregate demand curves. So take the aggregate supply curve first, for instance. The effect of the increase in productivity is to decrease the amount of labor needed to produce a unit of output, which is basically by reducing the cost for firms or producers. So this leads to firms to reduce prices they charge for any level of output, and hence the S curve will shift upwards or outwards, downwards, like that. And now for aggregate demand curve, does increase in productivity increase or decrease the demand for goods at a given level of prices? So there is no straightforward answer because productivity increases do not appear in a vacuum. For instance, what happens to aggregate demand depends on what triggers the increase in productivity in the first place. So let's consider two triggers. So if A increases comes from a widespread of implementation of a major invention, the aggregate demand will shift to the right and output will increase, as shown here, will shift to the rightwards and increases output from here to there. Why is this? This is simply because the prospect of higher growth in the future leads consumers to feel more optimistic about it, so they increase their consumption given their current income. While from the producer's side, the prospect of higher profits in the future, as well as the need to put the new technological in place, may also lead to a boom in investment. In this case, the demand for goods increases at a given price level, and aggregate demand curve shifts to the right. The second trigger is when growth comes from the efficient use of existing technology. Then this means firms will have to reorganize their production. So reorganization of production may require little or new investment. So increase in uncertainty and job security worries may force workers to reduce consumption and save more, and therefore the aggregate demand may shift to the left, as shown here. Okay, so even if we assume that we choose the favorable case, increase in A shifts the AS down and the AD up, such that output increases. We still cannot tell what happens to employment without having more information. What happens to employment and depends on whether the increase in output is proportionately more or less than productivity, because the two must increase in the same ratio for N not to decrease.